Hello Zach, this is Dylan Bishop for the final exam. This is the assembly portion, the part 1. We'll go through the code first. Up here I have the explanation for the wiring and what the code actually does. Then we go down, we include our files for this particular board, which I'm using the Arduino Mega board, which is the 18 Mega 2560, due to my Uno board being damaged. So to start off with, we start with a PV LED function, which is push button LEDs, what that stands for. And we start out by with the SPI DDR-B1, which what that does is it sets bit DDR-B, which is the register that sets whether it's an input or output of port B, and it sets it for pin 1. So that makes pin 1 of port B an output. And then right below it we have a CV high of port C, or DDR-C, which does the same thing for port C pin 1, except it's clearing the bit, which makes it an output instead of or it makes it an input, my bad, instead of an output. So we're going to be inputting a value from a push button on port C pin 1 and outputting that value on port B pin 1. So our LEDs on port B and the push buttons on port C. So then we go into this L1, which is loop 1. And we read in the value of pin C, which is the pin register, which is the input register for port C. It reads that value into register 16. Then it outputs register 16 on port B, which is the output register of port B. When it does that, then it loops. It jumps back to L1, so it just continuously goes through that routine. Doing that, it continuously transfers the value of that pin, of the pin C, to port B. So over here, which is still my capstone project here, so it's a little confusing on the board, but nothing else is hooked into from all this here into the Mega. So all we have here is we have our push button and our LED. As you can see, the LED has an input wire here onto the cathode, or onto the positive side, and the negative side goes through this resistor onto our ground. So the ground is plugged into that ground pin there. We have a positive wire coming from there going to this side of the push button, which goes through our push button, which has a pull down resistor to the ground, and that just pulls it down, so it's always a 0 unless it has power flowing through it. Then it gets this wire here, comes up, this one here, sorry about the same colors, and it comes over here into pin 36, which on the Mega board happens to be pin 1 of port C. And then port B pin 1 happens to be this pin 52 over here, which outputs on this orange wire, which comes over here to the LED. So when we do this, when we push the push button, the LED will come on, and when we let off of it, it goes off. So it's not latching, it follows when that push button is being pressed. Next we'll go into the C programming, which is a separate video, but I'm going to splice them together. Thank you. So this is the second part of the final exam, the C programming part. Here, this is the actual program that I've developed, and as we can see here, it has name, author, and all that. This here's the description of the wiring, the actual hardware wiring, and this description here is actually the description of how the program operates. and then this is just a little note identifying that it's using the Arduino Mega board instead of the Uno. If we go down to the actual program, here we have two include files for the regular AVR and then the interrupts. The input outputs, this one, and the interrupts. Then we initialize two variables, an RL state, which is red light state, and we set that to 1 here. And all that does is that will be used later in the program as it identifying which state the machine is in. And we want to start in 1 because we want to start in state 1 because we don't have a state 0. Then we have a second variable here, timer val, which stands for timer value. We're going to start it at 0 because we want to start at 0 on our time. Then we go down into our actual main loop where the process actually starts. Here we can see our 3 setups. So we set up our ports, our timers, and our interrupts. Once all those are set up, which we'll look at here in a minute, then we come down and it's kind of hard to see with it highlighted, but it's an update outputs subroutine. And it actually inputs the RL state value. It takes that value. We call that subroutine right here for one reason, and that's to start the red light. So it'll start as soon as the program begins. It'll actually put it into state 1 as the timer begins. Then we'll come down here, and we go into this while loop. And all this is doing is this is sitting here basically stationary and standby. It's just circling here because there's nothing for it to do. And this would be if you wanted to transfer data from one port to another, a pin, or if you wanted to have something else blinking or some other operation occurring during this while the red light's operating, you would put that here because it's going to do whatever operations in this while loop while the timer is timing. Then the interrupt will activate and stop the CPU, do this interrupt right here below it, and then come back to whatever it was doing. So now we'll go down, we'll look at the timer first because that's what's next on the list. So we set up, or we'll go down and look at the actual setups and then come back to that, make it a little bit simpler. Here we have our 3 setups. So we set up our ports, which just sets up port D as an output. DDRB equals 1 or high. So it'll set up it as an output. Then the next one was a timer. It sets this up here, which is one of our registers. I can't remember the specific name of it, but it actually, this 31248, that's the value. It's actually the value for 2 seconds. Because timer 1 cannot count up to 10, we're going to use the highest multiple we can to create 10. We can count up to just over 4 seconds. So we can't do multiples of 4. We're going to have to use the highest multiple we can use as a 2. So that's why we're using a 2-second timer. Then this here sets up the control registers, A and B. B, we actually have hex D put in, which puts it at a normal state with a prescaler of 1024, which is our highest prescaler. Then we go back to the main and come back to this setup for the interrupts, which sets up this interrupt here, which basically it compares, and whenever it reaches those two equal each other, basically it will throw the interrupt. So this sets up our interrupt for timer 1, and then this actually initializes our timers. So then once all that's complete, it comes back up here to this main loop, which is where we're here. Then we'll look at our interrupt actual. So this is our interrupt for timer 1. It's timer 1 compare. And what it does is when it comes in, when it throws the timer, it'll come into this line here, which increments the value of timer value. And what that does is, so if we're starting at 0, after 2 seconds it goes to 1. So in that state it would go 1. It looks, is that value equal 1 or equal 5? I'm sorry. If not, it returns back to the program. Otherwise, and then it goes back to that while loop, doing whatever it needs to do. When the interrupt does again, it increments. So it'll do that until 5. So 2 times 5 is 10 seconds. So when the timer value equals 5, we increment the red light state. So we'll go from state, if we're still in state 1, it'll go to 2. Then it will reset the timer value, and then it updates the red light state. So it calls this red light, or this update outputs, and it takes in red light state number. So if we just went to 2, we'll come all the way down here to this last function, which is update outputs, and it takes in this number here. And what it does is it takes in that number, and it will read all this in here. So we're going from case 1, or state 1, to state 2. So this looks down through here at all these cases, and whichever number that is, it will select that case. So we're in case 2. So we come down and it actually outputs this to port B. It outputs this binary number, which has this number 1 and this number 1, which is north-south red and east-west green. So we'll go from both reds to red-green, because state 1 is both reds. And we continue down through here, through all the different functions. So we'll actually have 6 states to the light. On the final state, it actually has a red light state 0, so it resets the state. When it does that, it actually will, it resets it back to 0, which is the next state from this, which is east-west yellow, east-west red, goes back to 1, which is red-red. So now that we've looked at that, I've already loaded it onto this board here, which I'm going to reset so that we can see it from the very beginning. So when we reset it, we go into state red-red, and it'll sit in this state for 10 seconds. And then it should go one of them to green. So this one over here is our east-west. So it goes to green. After 10 seconds, it'll go to yellow, and then back to red again after another 10. And then it comes over here to green, yellow, red. And so it'll continue this state continuously. So we'll sit here and watch the full continuous state. So in this, we went back to our original state 1, and now we're back into state 2. So we've done our full cycle, and it'll just continuously do this. So if we look at our wiring, it's kind of hard to do on this where it's nice and neat. We have this black wire here, which comes from ground, and it comes over into this rear pin here, which is kind of hard to see on these little things here because they already have their resistors built in. But it goes from there and actually has a jumper coming over into that one for ground. So they're both grounded off the same lead. So for east-west, we have these 3 wires here, a green, an orange, and a red. So they come out of that. And they actually come over into these pins here, which is 50, 51, which is 51, 52, 53, which is those 3 right there. It's kind of hard to see on this, but that's the that's port B 013. That's those pins. Then we have this other green wire here coming out on pin 50, which comes over, and it comes into this light here for its green wire, or for its green light. That's pin 4, or pin 3 of port B. Pin 4 and 5 actually are not over there with those. They actually come over here to pins 11 and 12 on the board, or 10 and 11 on the board. So we can see them here where they're plugged in. So that's the yellow and the red for the north-south. So that's the basic wiring of this light here. If you have any questions or need any more validation or answers regarding this project, feel free to contact me. Thank you.